Hello, I'm just going to do a quick video here about doing some debugging with XRoar. So I'm actually here on my CoCo Pi, and I have a script here which runs a development version of XRoar on CoCo 3 with IDE cartridge. I'm running HTTP DOS, and the thing I'm actually testing is I have this special hard drive image set up. So let's see what happens if I actually run this. All right, need to move this. XRoar starts up here. So one of the cool things that you can do with XRoar is you can actually connect GDB to it. I have the options here. It's listening on localhost on this part. So in this window, I have GDB running. And what I need to do is attach it. Localhost, localhost 6.520. And if you actually look at this, you'll see that it shows me what address it's on, what instruction it is, like that. And it says that the current address that we're at, according to PC, is A7D5. So that should be someplace inside of the color basic ROM, A7D5. And there it is. Delay while decrementing X to 0, it says. So if we just want to check this out a little bit, it says we should be on this BNE branch. If not equal to 0, go back to the line before. Okay. So we see, yes, BNE A7DE. We see the registers. There's no 0 here, so it's going to loop back. Yep, decrements X by 1. We can do is display X register. It's 12. Now X is 11, 10. Oh, this is hex, so this is 15, 14, etc. The other thing I have going on in here is I have a breakpoint. This is called a watch point. If anybody accesses this particular address, then it's going to return me to the debugger. That's what I want. This is actually one of the registers on the Glenside IDE. All right, I type continue, and now the emulator is running. So let's type DOS. It should try to load this thing from the hard drive, and boom, it died. What happened? On the other screen here, it says segmentation fault. Uh-oh, big problem. Okay. Something is definitely going wrong here. So what can we do about this? We can do GDB inception. I can actually run GDB on XRoar at the same time I'm running it on the emulation. So let me get the emulation part set up first. Target remote. Oh, it's not gonna work. Said it failed. Okay, let's restart this. Okay. So it says that it's listening on that part. I have to type that correctly. All right, we're in. So we want a watch. This is an access watch on FF57. Okay, So if anybody does anything on FF57, all right, so now we need to have the GDB inception. So I have another GDB here. I'm running this on XRoar. So all that I need to know is the PID number of XRoar, and I can attach to it if I type that correctly. All right. All it says attach 6032. If I take a look at this, I'm inside of XRoar. It's running CoCo 36809, etc., etc., etc. We actually don't care what it's doing. We can just tell that to continue. So now we have GDB inception. This GDB here is on XRoar. This GDB here is on the CoCo running inside of the XRoar. So now if I type DOS and try to boot this guy up, we'll actually capture the error that happened in GDB. If I get a backtrace, it'll show me exactly what happened. Basically says we're doing a CPU cycle, doing a read hook, this looks like a breakpoint hook. Frame 1 list, yeah. So this looks like some if-else logic. It's basically saying we're at line 215. It's trying to call a breakpoint handler. Let's take a look at that. Let me do it like this, BP handler. Huh, that doesn't look right. If I'm reading this code correctly, this is supposed to be a handler for the breakpoint, and the function is 0. So of course that's going to blow up. If you actually look at the backtrace here, it actually went to adjust 0 and then blew up. Okay, well, here's how I can actually fix this. Let's let this continue. All right, yep, it got killed. So I have it on good authority that, okay, git diff, really? Sure. I'm pretty sure I made a change in here, but okay. So Karen, the developer, basically said he made a change. A couple changes, it looks like. This one was earlier, and then he added a chop and added some sanity stuff. So what we need to do is let's make sure that we have no debugging. We just say make. It will rebuild the code that it needs to make. And then we can try this again. All right, our debugger is listening. Target remote localhost 65520. Our watch point is still there. Let's let this continue. And let's pretend we don't need to debug XOR this time. Let's just type DOS over here and see if it does any better. And it does. It says that I reached the breakpoint. Where is the breakpoint? Display /IPC says I'm at DAB3. This looks like it's inside of a disk ROM. Let's go find that code and then we'll take a look. Okay, so I'm in my HDB DOS here. Let's have a look at HDB LBA. dot rom dot listing. This is a printout of what the assembler gives us. So we just go down to DAB3. And here we are. So this is an IDE busy routine. It's basically has tested the status and it says branch on plus. Branch on plus means that this is signed. So that means that the um, bit number 7 has to be clear. So let's have a look. Examine byte at FF57, and it says that it needs to be clear, which it is. So that means that we should actually take this branch, and that means we should go down here to DABE. It's step 1 instruction, and we go to DABE, we save it, and then we return. So now we're at DAC8. DAC8. It says BNE return. This tests the 0 flag. If the 0 flag is set, then we take the branch. So we can take a look at the registers on the machine. 0 flag is set. So since the 0 flag is set, it means we are not going to take this branch. We should go down to the next instruction, which we do. And what are we going to do now? We're going to prepare to send a command. Let's let this thing continue. All right, we jump down to somewhere else. We're at DB1B, which is just a couple lines down here. DB1B, we're down here. And it says branch if minus. So this is testing the negative flag, which is not set. We are not going to take the branch. We do a shift. Okay, now it says branch on plus. So we have negative set. We are not going to take the branch. So it's going down here. Anyway, this is just an example. Let's continue. Now that this is not blowing up, I actually want to remove this. Delete 1. Okay, what I actually want to do is this is doing something really weird. It's trying to talk to drive wire, which it's not supposed to do. So I'm going to put a watch on FF41, which is the Beck report. And let's continue. Nope. It's not going on FF41. Well, let's see where we're at. Oh. We're in some kind of a loop. LDB8, comma Y. FF48. FF48 is actually the disk controller. So, yeah, this is completely not what this is supposed to be doing. What can we actually do? We can try to examine memory a little bit. Try to figure out where we're at. Yeah, this is a little bit tricky to figure out where we're at. But anyway, I wanted to show us a little bit of debugging. So I'm going to sit here and try to figure this out where this seems to be going sideways. So continuing on a little bit more, let's see if we can figure out what code we're actually running inside. So something that we can do is we can look at a little bit of memory around this point. 16x. All right. So the instruction that we're on right now is this E628, which might be a lot of places, but the next one, C501, that might not be very many places. So I think what we can do is can go over to this is my Nitrous 9 build directory. So let's just grep for some of these things. Grep for E628. Not too many places. That's actually pretty good. Let's look at the first one. Boot 1773. So looking for E628. So here's one. C9. So no, it's not this one. How about this one? E628 C501. Yeah, it looks like we're here. FDC loop. So this means that this is absolutely, definitely trying to boot from the floppy disk. And we're supposed to be booting from IDE. That means that I have done something very, very wrong, and I don't know how this happened. Wow. Okay. I guess that ends this session. So, a couple of days have passed since I recorded the previous video segment. Actually, very shortly after I finished that, I figured out what the problem was. The boot disk that I was using was created by some scripts that I wrote. And since it was not booting the correct thing, that sort of indicated that the boot disk was not the right boot disk. So I figured out this highlighted section of the script. The script actually wasn't finished. This highlighted section actually creates the boot disk. It actually deletes the old boot disk if it's there, and the line that actually got forgotten was the os.system that actually runs the command. Yeah. So the command that's actually being run is format to make a new boot disk. So this line here was missing. So it didn't create a new boot disk. And then this line here was also missing. This runs OS9 gen that actually copies the boot files into this floppy image. So with those lines missing from this script, it was not creating the boot disk properly. And not creating the boot disk properly means that it didn't boot properly. With those resolved, it actually does work just fine. So I can now show you, if I run this, it'll start up XRoar, and it will actually boot completely off of the IDE drive. Okay, so here's my XRoar. It's got the disk image that the script created, and if I type DOS, this is only 6809 right now. 6309 is not working, but it boots straight in, and we're running Nitrous 9 ease of use beta 6. So 2021, 12, 10, it's currently 10:43 and 55 seconds. Actually, this right here. This is the 6809 version. 6309 version caches here, but I'm still working on that one. But this will come up eventually after it loads everything. Yeah. So I guess the moral of this story is that when things go wrong, check your work. Okay. What the mode? If I take a look at this, we see that this is an RB super driver and it's at address FF50. So this is definitely running off of the IDE controller. So that's it for this video. Bye guys.